Hello there guys, and welcome back to another epic inexorable maths video. In this video we're looking at proving that the square root of 2 is an irrational number. What is an irrational number? An irrational number is a number that cannot be expressed as a fraction of two integers, two whole numbers. You cannot write the square root of 2 in the form a over b, where a and b are whole numbers. You cannot do it. It's impossible. You might say, well, what if a was like really big and b was another like really big? No, it's impossible. And we can prove that it's impossible to do this. Root 2 is an irrational number. Let's begin. So the way that we're going to do this is by contradiction. What this is it is basically the assumption that we're going to make that root 2 is rational. We're going to intentionally assume the opposite of what we are trying to prove. And we're going to prove ourselves wrong. It's quite clever. So, first steps first. We're going to say the square root of 2 is a divided by b. A and b need to be integers. So that's a thick Z, you know. It's just integer. Just means a and b are whole numbers. They're probably both going to be positive, of course, because the square root of 2 is a positive number. We can say that. We can also say that a and b are co-prime. What this means is that a and b do not share any common factors. This is the simplest way to write the square root of 2. There's no division that's needing to happen here. A and b cannot be basically multiples of the same number. They can't both be multiples of 2 or 3 or 4 or anything like that. They are in their simplest possible form. That's the assumption that we're going to make. Okay, now, here's the thing. If we can just continue with correct mathematics until we get to a point where we're obviously wrong, then we've proved that something must have gone wrong at some point, and as long as we're satisfied that every step that we've made from now on is okay, the thing that must have gone wrong is the initial assumption that the square root of 2 is rational and can be written as a over b. So let's just see it in action, and then I'll kind of talk more about why we can actually do this and what this is. So if the square root of 2 can be written as a over b, then that means we can square both sides, and that means that 2 is equal to a squared divided by b squared. We're just squaring both sides because they're equal to each other. We can then multiply the left and the right hand side by b squared, and we get that 2b squared is equal to a squared. This means that a squared is a multiple of 2, because b is a whole number, a is a whole number, we've already said that, which means that a squared is 2 times some number. Now, b squared might be even, it might be odd, we don't know, it's one of them, but it's being then squared and multiplied by 2. So regardless of whether you square b and it's odd or even, it doesn't matter, you're timesing it by 2. If you times any number by 2, it's even, which means that a squared must be even, according to this. A squared needs to be even for this to make any sense. It must be even because it's a multiple of 2. It's 2 times b squared, whatever b squared is. If a squared is even, that means that a must also be even. Because think about this. Any number that's been squared, think about any number, the square root of that was always an even number, right? Like 4, okay, the square root, well, it's 2, it's the even number. 16, 4, okay, even number. 36, 6, okay, even number. Try it with any number that you want, it's always going to be even. So if a squared is even, a is even. Okay, so if a is even, then we can say that a is equal to 2 times some other integer. I'm going to say k. K is just some other whole number. The reason we can say this is because an even number by definition is just 2 times any integer that you want. That's what it is, it's fine. Because any time that you double or times by 2 any integer, regardless of whether it is of whether it is odd or even, if you times it by 2, it will be even, which means that we can write a as 2k. Now, we remember the original equation, 2b squared equals a squared. So I'm going to write that down again. 2b squared equals a squared. Well, we know what a squared is now. A squared is 2k. So 2b squared is equal to 2k squared. If 2b squared is 2k squared, then we can expand this out and we can get 2b squared is equal to 4k squared, like that. And then maybe we can divide both sides by 2. So b squared is equal to 2k squared. Hold on a second though. Do you see what's happening? Because now we're being told that b squared is also a multiple of 2. It's 2 times some integer that's been squared. It's even. So b must be even. B must be even. Has to be. B must be even. Using the exact same logic as before, or rather b squared must be even, but as I was just about to say, using the exact same logic as before, that means that b itself must be even, okay? So b squared is a multiple of 2, that means that b is also even, it's a multiple of 2 in and of itself. But hold on a second, remember what we said originally? We said that the square root of 2 was a over b, but we've just said that if we make this assumption, then a is an even number, and b is an even number. That's actually an issue, because if a and b are both even, then they are both multiples of 2, and therefore they are not co-prime, which, remember, this is the original thing that we said. We assumed that the square root of 2 can be written as the quotient of 2 whole numbers, but we also said here that a and b are co-prime, which means they share no common factors. They share, though, we've proven, a common factor of 2, which means that we must have made a mistake somewhere in this working out. I personally am satisfied that we have not made a mistake below these square brackets. I don't think that we've made a mistake anywhere over here at all. You can check it again, it all is sound. Therefore, the place where the mistake must have originated from must be this assumption. The square root of 2 can be written as a over b. That's what's causing the problem. That's what's causing the maths to break. Because we've clearly contradicted ourselves. We have said a and b are co-prime, and later worked out that they are not. So there must be an issue somewhere. The issue is assuming, in the first place, that root 2 can be written as a over b, which it cannot be if a and b are integers. Therefore, we can go to the bottom of the page, and we can say, therefore, the square root of 2 must be irrational, which means it cannot be written as a over b. Thank you guys so much for watching. I highly appreciate it, and I'll see you in the next video. Cheers.